everyone, welcome to the channel. In today's video I am to talk about BIRCH clustering. The full form of this BIRCH word stands for balanced iterative reducing and clustering using hierarchies. In this video I will basically show how we can implement BIRCH clustering. I will not discuss the theories. If you are interested in knowing the theories, I will provide the Scikit-Learn documentation link. You can check that out, and I will implement BIRCH clustering using a popularly known dataset, which is Titanic dataset. So let's get started. So as usual, we need the required libraries. So we need NumPy, and finally we need matrix from Scikit-Learn. Okay, so these are enough. Now let's load Titanic dataset. So let's name it Titanic, and Titanic dataset is available in many places, but I want to load it from Seaborn. So load dataset, and we have to just mention Titanic here. Let's see. Okay, so this is the Titanic dataset. 891 rows and 15 columns. I don't want to use all the features. I want to use only selected features. So let's select a few features from this dataset. Features and targets. Look, let's name it features. So only select column. I need passenger class, which is P class, first class, second class, third class. P class. Then I need sex, male or female. Also I want to select the fare. So fare will be high. So this column fare will be high for first class. We can see for first class is 71.28, most probably pound or some other currency. And finally I want to select embarked. So embarked is a boarding town for a particular passenger, so Southampton, Cherbourg or Queenstown. Okay, so these are the 4 features that I want to use. So this is the new data frame that contains the features. Okay, so from 15 columns I have selected only 4. Those are rows remain the same, and I also need the targets. So targets is easy. So survived column will be the targets. There are two different types of values in this column: 0, 1. 1, 0 means didn't survive, and 1 means survived. So let's select this column, survived, targets. Okay, only one column. Now I can see a few nan values in this data frame. So nan values here. I didn't select this take column, but I selected this. I don't think I selected age either. Okay, just let's check whether there are any nan values in our features and targets or not. So let's first see we can see the unique levels in this. So 0 and 1 did not survive, I'm survived. And let's check survived the NaN values. Okay, so there is no NaN values in the targets. Now let's check the features as well. Features is null any. This is the same command like this one, just different way of writing. Okay, so in case of features we have few NA values. Let's see which columns have the NA values. So is null sum. This will give us the total NA values per column. Okay, so we selected 4 columns as our features: passenger class, sex, fare, and the boarding town. So in case of boarding town, there are 2 NA values. So next we need to fill these NaN values with some value. So I want to use the forward fill method. So features dot fill NA. Let's mention fill. Now let's check. Okay, now whether you are able to fill the NaN values or not, we can check using this line. So in case of features, it will be TF. But previously it was true, now it is false. So we have filled out the NaN values. Okay, now there are some categorical values in couple of features. So A, C, Q, male, female, these are not numbers. These are categorical values, and these are not good for algorithm. So we need to convert these categorical values to some numbers. So now let's replace categorical values with some indicator values or numbers. So this is our data frame currently, and we can use pandas get dummies. Pass in, sorry, this will be new data frame. So pass in our existing data frame and also mention the columns that contains categorical variables, in this case sex and invert. Okay, so previously we had 4 columns. Now after replacing categorical values with indicator values, we have got 7 columns. So there are 3 types of information in BIRCH, and when A was detected, there is a 1 in case of BIRCH case, and other 2 cases 0. Similarly with C and Q as well. And when male was detected, in case of male it's 1, in other cases it's 0, vice versa in this case. Okay, now we can perform preprocessing. So scalar dot fit transform plus in our new data frame. You can also check the shape. So same shape as this one. Now we can create a scaled data frame. So let's name it df scaled dot data frame scaled. Columns will be new df dot columns. Okay, now let's look at that. We can see 771, 753. Now if we look at this, now this is within a scale. So I think these values are within 0 to 1, if I'm not wrong. Okay, now so we can perform the birch clustering. With 2 clusters. 2 clusters because our targets contain 2 types of values. So this is our target column. Did not survive and survived. So that's why we need to perform 2 clusters. Perform clustering with 2 clusters. Okay, so birch n clusters will be 2. Then birch dot fit, we need to fit our scaled features. So these are scaled features. We need to fit these values. Then we get the grades. Okay, now we can add 2 new columns to the scale data frame. So df scaled on will be our target column, and another will be the prediction by birch clustering. So prediction will be grades. Now let's visualize. So now we have 9 columns. Previously we had 7. All the features. Now the last 2 are the target column and prediction column. Okay. Now we can also check the shape, which will be 891.9. Okay, now we can perform a clustering comparison. between targets and predictions. So we can obviously see the confusion matrix. We need to provide targets and threads, and let's visualize the confusion matrix. So size, let's say 74. SNS dot heat map, same out true. Okay, now we have to mention the labels. This will be target, font size 25. Reality.xtix, font size 25. This will be ytix. Okay, so let's visualize. Sorry, this will be column. Okay, so this is our confusion matrix. Okay, so let's first see the value counts. So this will be bracket, and also let's see the value counts for prediction. So don't think it will fit in the window properly. Okay, so actually 549 passengers did not survive and 342 survived, but the birch clustering prediction is 614 passengers survived and 277 did not survive. And see, out of 549, 477 have been predicted correctly by the clustering algorithm, but in case of survived, the results are much worse compared to not survived. I think we can check the accuracy. So round matrix dot accuracy score, target spreads till 4. So accuracy is around 76%, decent. One final thing that we can do is visualize predictions. Red and So 0 means no or didn't survive, 1 means yes or survived. Let's use the marker ticked as well. So double. Okay, let's select two features. So we can select passenger class from our 4 features, and let's select fare as well. Figure figure fixed size. Add subplot. So these are our predictions. These are predictions, and we need x, j, y, j. Color will be color ticked I. Okay, so finally set example passenger class font size, let's say 20, and this will be available. This is ticket fare. Sorry, x dot x set ticks 1 to 3, because x-axis has the class. There are 3 classes: first, second, and third class. X dot legend. We can mention the title, which is the survived. Font size, let's say 20. Title font size 30. Okay, so this is the clustering prediction visualization. So yes means survived, and no means did not survive, and red ones are did not survive, and this is class wise. prediction. Obviously not all of these are true because these are the predictions, and we have seen that there are some wrong predictions by this BIRCH clustering, but accuracy is decent, around 76%. Okay, so that's all for this video. I will provide the Scikit-Learn documentation link. You can check out the theory of parse clustering if you want to. So that's the end of this video. Thanks for watching.